Hello, everybody. This is Pablo Bermejo. I'm from Multiverse Computing, and I work on quantum algorithms, quantum computing. So, since this is a broad audience, I will try to guide you through this course with the basics of quantum computing, just to give some brief introduction of what it is, the limitations, and the things that we will be doing for this Ignite project. So, to start with, I would like to remark that nowadays, there are some difficulties in order to implement quantum algorithms because of the limitations coming from quantum hardware. But I would like to put the light on the fact that here we are not aiming to complex algorithms like Shors or Grovers that I'll be commenting on just in a few minutes, but algorithms that are that target quantum circuits that we can build with the quantum hardware we have today. Okay, that's a very very important point. So starting with the presentation, uh, for those that are interested in quantum computing and the things that we do at Multiverse Computing, which is basically quantum machine learning and quantum optimization. The reason behind this is that we think that these two fields are the ones that will benefit sooner from the advantages coming from this new trend of quantum computing. Okay, just for your information, there is this kind of a Bible about quantum computing and quantum information, which is Nielsen's book, right on the left corner of your screen, and also, well, some papers that I'll be talking about later on, devoted to algorithms to produce quantum machine learning advantages and so on. Okay. Also, I would like to highlight that there exists this repository full of articles devoted to quantum physics, mostly quantum computing. Okay, it's called arXiv from the Cornell University. So in case you are curious about it, please go ahead and check it out because it's very useful. Many scientists uploading information every single day about their work. Okay, before sending the documents to actual scientific journals. So yeah, getting into this whole quantum computing stuff. Okay, as you may know, quantum computing started like 20 years ago, 30 years ago, um, by this idea coming basically from Feynman that, okay, he thought that quantum systems uh, could be preferable to be simulated by means of other quantum systems. Okay, so after that, some clever guys came up with ideas to actually take advantage of how information is encoded in quantum systems in order to develop quantum algorithms useful for many other tasks. Okay, not only related to the quantum war. Okay, so here I would like to remark that there exists some well-known algorithms, such as I was saying, Shors or Grovers, that accomplish a very specific task. Okay, for example, Shor's algorithm is devoted to quantum factorization, Grover's to searching in an unstructured data set. But it's important to remark that these algorithms are composed of, let's say, modules, okay, which can be understood as algorithms themselves, okay? And here there's a list with some of them. You can see on the screen that we have this quantum Fourier transform, okay, which is the core of Shor's algorithm. We can see that we also have this quantum amplitude amplification, which will be part of Grover's algorithm. Okay, so since it's been a lot since the first algorithm came up, okay, we have reached this level of deepness, somehow they feel. So right now we count on many different approaches, okay, to solve many different tasks. Okay, as you can see, there's a long list in there, but again, I would like to say that we are not so interested in these ones, but the ones that are currently implemented, okay, that can be implemented in the current devices we have today. Those are the ones that Multiverse is interested in, and the ones we will focus on for this Ignite project. Okay, as you will see soon enough, those are the ones related to variational quantum algorithms. Okay.